Hello everybody, welcome to my your programming club. Today we will solving another Leetcode daily challenge and the challenge name is longest arithmetic sequence of given difference. So the challenge statement is like this. Given an integer array ARR and an integer difference, return the length of the longest subsequence in array ARR, which is an arithmetic sequence such that the difference between the adjacent element in the subsequence is difference. So what the problem is saying is, just wait a second. Yeah. So problem statement is saying that given an integer array, it will be like this. We have to find the longest subsequence. Those of you who do not know what a subsequence is, the problem further explains. A subsequence is a sequence that can be derived from array by deleting some or no elements without changing the order of the remaining elements. So for example, if the array was like this 1 2 3 4 5 1, then what would be a valid subsequence would be if we delete some of the elements. For example, if we delete 2, here we'll delete, let's say, 4 and 1, then what would be the remaining elements? These would be 1, 3 and 5. So this is a valid subsequence. But for example, if you might be thinking like 5 3 1, is it a valid subsequence? No, it's not a valid subsequence, since the order in which they were present in the array from left to right is not preserved. So this is not a valid subsequence. That's what it's also saying, without changing the order of the remaining elements. Okay. So let's move towards the constraint part, and we have to find the longest subsequence such that the subsequence is an AP arithmetic progression with difference or common difference as difference. It would be given, difference would be given. So we have to find longest subsequence provided this condition satisfies length of the longest subsequence, its length. So let's move toward the constraints part. So here constraints are length of the given array is 10 raised to power 5. So for a 10 raised to power 5 length, n log n solution is acceptable, and n square solution is not, because those of you who are thinking of brute force ways to just run two nested loops, for loops, and just checking for let's say you want to check for 5 what would be the longest subsequence such that this condition satisfies, then you would be checking for current element, let's say it's 5, you would be going backwards in the array. For every element you will be going backwards, so the time complexity will be scarce. So it would give us TLE because 10 raised to power 5 and 10 raised to power 5 is equal to 10 raised to power 10, and we are allowed only 10 raised to power 8 operations. Those who are not familiar with how the time complexity of the accepted solution changes or varies with the given input size and time complexity of accepted solution relation, I will be providing a link for this. You can check it out. Okay, so what would be what would the approach of this problem would be? So if instead of going back, if we could somehow store for each in, so what IAP is, for example, if let's say the common difference was 1 and the starting number was 1, and then we have IAP like this 2 3 4 5. Let's say we are checking for fifth number, or say 5. Let me quickly change the color. Let's say we are checking for this number. Then what we have to check is what was our answer. What was our answer? Or say longest subsequence length for just previous element in the AP, one previous element. So one previous element was 4, one previous element was 4, which is nothing but current element, which is 5, minus difference given, which is as of now 1, it's equal to 4. So this is the previous element. For that, if we know or remember, let me quickly change the color again. If for previous element, remember what was longest subsequence length, provided that it satisfies this condition. What is the condition? This is the condition, this one, such that it's an AP with common difference, with difference. So remember what was the longest subsequence length for previous element. So we can just simply add 1 to it for the current element, because the length would be increasing by 1 if we have remembered what it was for previous element. And if simply the previous element is not present, for example, let's say if we are checking for 1, then its previous element would be 1 minus difference is equal to 0. 0 is not present, or we haven't encountered 0 in our array. So we won't be doing any operation for that. We would simply be returning 0 for previous element and adding 1 to it and storing it as the result for current element. So how we would be storing this result for the current element and the previous element? We would be using a map. It may be a map in C++ or a hash map in Java. Or a similar data structure in your preferred language. So that's pretty much the crux of the problem. That's how we would be solving it. And at last, how we would be getting the maximum. Let me quickly change the color again. How we would be getting the maximum length subsequence. What we would be doing is, let me take another slide quickly. We would be using a variable, max length, or say longest length, and for each element under consideration, for example 5, we would simply be checking if this value is greater than the maximum length subsequence till now. If that's the case, we would be updating this variable, or you can say this variable, and simply be returning it at the end of our program. And that's the solution of the problem. Let's move towards the coding part. So this is the longest subsequence length. We would be returning it at end. So this is the map I was talking about. We would be storing result for each element under consideration. So let's check what we would be doing. We would simply be traversing the array once. If the current element under consideration is this, and what we are looking for, what element we would be looking for is just previous element in the arithmetic sequence, if the arithmetic sequence at all exists, subsequence at all exists. So this is the element that we would be looking for. And yeah, if the element that we are looking for is present, then it would give us the value that was the longest subsequence length for that element when it was discovered, and we would be adding simply 1 for the current element, because the current element would be increasing the length of that arithmetic sequence by 1. So, and then we will be simply checking if simply updating our longest subsequence length, and we would be returning that at the end. So that's pretty much it for the problem, and that solves our problem. So the code would be available in both of the languages, C++ and Java, on the GitHub repository. Subscribe to my channel for more such content. Thanks for watching. Thank you.